When you connect a generative model to a knowledge source so it can answer questions with fresher, more specific information, you get something that feels incredibly useful and also quietly risky. This pattern is called Retrieval-Augmented Generation, RAG, and it matters for Security AI Plus because it turns a model from a general talker into a system that can pull in internal documents, tickets, logs, or policies and then speak about them fluently. That fluency is a double-edged sword in security because the same mechanism that helps a user find the right information also creates a path for exposing the wrong information. A beginner might assume the model will automatically know what is confidential and what is safe, but our AG systems do not magically understand organizational boundaries unless you build those boundaries into the design. The goal is to keep the benefits of retrieval while preventing abuse, preventing leakage, and preventing the model from becoming a convenient exfiltration tool. If you can reason about our AG as a pipeline with controls, you can answer scenario questions with confidence and avoid the common trap of treating it like a feature instead of a security system. Before we continue, a quick note. This audio course is a companion to our course companion books. The first book is about the exam and provides detailed information on how to pass it best. The second book is a Kindle-only ebook that contains 1,000 flashcards that can be used on your mobile device or Kindle. Check them both out at cyber.author.me in the Bare Metal Study Guide series. To design our AG defensively, you first need a clear mental model of what it is at a high level. A user provides a question. That question is turned into a search intent. Relevant content is retrieved from a corpus, and the retrieved content is placed into the model's context so the model can generate an answer grounded in that content. The model is usually a large language model, LLM, which means it generates text based on patterns and context rather than retrieving exact database rows like a traditional query. The retrieval step can be meaning-based or keyword-based, but the important point is that retrieval selects what the model gets to see. That selection is the control point that often determines whether the system is safe or leaky. If retrieval is broad, sloppy, or poorly governed, the model may receive sensitive content even when the user should not. If retrieval is tightly scoped, access-aware, and monitored, the model's best available knowledge becomes aligned with what the user is allowed to know. In security terms, our AG turns information access into an interactive conversation, and conversations are easy to probe, so the pipeline must be designed to resist probing. A simple but powerful way to think about abuse is to treat the user's question as untrusted input, even when the user is well-meaning. Untrusted does not mean hostile. It means you cannot assume the input will be safe, correctly scoped, or clearly phrased. In our AG, user input can cause retrieval to fetch unexpected content, and it can also cause the model to transform and present content in ways that reveal more than intended. Attackers can be more deliberate, crafting queries that are designed to pull back high-value documents, to infer what documents exist, or to force the model to reveal details that would normally be hidden. This is especially relevant when the corpus includes incident reports, architecture diagrams, credentials and notes, or personally identifiable information. Personally identifiable information, PII, should be treated as a special category because even small leaks can be damaging and can create compliance exposure. A defender's mindset says that if a system can retrieve sensitive text, someone will eventually try to retrieve it in an unauthorized way, so the design must assume adversarial curiosity rather than polite usage. Data spillover is the specific failure mode where information flows to a place it should not go, either because retrieval grabbed too much, because permissions were not enforced, or because the model combined multiple pieces of data into a revealing summary. Spillover can be obvious, like directly repeating a confidential paragraph, but it can also be subtle, like revealing project names, customer identifiers, or internal procedures through hints. It can also happen through aggregation, where each retrieved document is individually non-sensitive, but the combination creates a sensitive picture, such as revealing how detection logic is tuned or where a critical system lives. A beginner misunderstanding is thinking spillover only happens when the model quotes a secret, but modern leakage is often about inference, context, and pattern. The model can be prompted to produce a list, a summary, or an explanation that stitches together sensitive details from multiple sources. If the system includes conversation history, a user might also collect small pieces over time, gradually building a sensitive understanding without ever asking for a single forbidden fact. Defenders therefore design RAG to limit not just direct disclosure, but also the ability to assemble disclosures. The first major defensive design pillar is access control that is enforced before retrieval, not after generation. In a secure RAG system, the corpus is not a single pool where anyone can search everything. It is segmented by authorization boundaries. This is where concepts like role-based access control, RBAC, and access control list, ACL, thinking matter, even if the system is modern and semantic. The user's identity and permissions should define what documents are eligible for retrieval in the first place, so unauthorized content never enters the model's context window. Post-generation filters can help, but they are a weaker safety net because once sensitive text is in the context, the model can reference it in unpredictable ways. A defender prefers preventing exposure over trying to detect exposure after the fact. This also protects against accidental leaks from well-meaning users who do not realize they are asking for something sensitive. If a scenario question asks how to reduce data spillover, the strongest answer is usually to enforce least privilege at retrieval time so the model never receives unauthorized content. The second defensive pillar is careful document preparation, because retrieval quality and leakage risk are shaped by how you chunk and label content. If you split documents into chunks that are too large, retrieval may pull in irrelevant sensitive sections along with the relevant parts, increasing exposure. If you split documents into chunks that are too small, retrieval may lose context and return fragments that are misleading, causing incorrect answers that can create operational risk. Chunking is therefore both a security and reliability decision, and defenders treat it as part of the data pipeline. Labeling and classification of content also matter because the retrieval system needs metadata that can be used to enforce policy, such as sensitivity level, ownership, and allowed audiences. A beginner might assume metadata is optional, but without it you cannot reliably prevent cross-boundary retrieval. Another important practice is to remove or mask obvious secrets before documents enter the retrieval corpus, because secrets often live in places people forgot to sanitize, like ticket notes or troubleshooting guides. If you reduce sensitive content at the source, you reduce the blast radius of any retrieval mistake. The third pillar is retrieval controls that reduce the chance of overbroad or manipulative queries succeeding. In classic security, you rate limit login attempts because repeated attempts can reveal patterns, and our AG systems need similar thinking for queries. Query limits, anomaly detection on query behavior, and auditing are essential because semantic retrieval can be used for reconnaissance. If a user asks many variations of a question that appear designed to discover hidden documents, the system should treat that as suspicious. Retrieval systems can also apply policy-aware query rewriting or intent validation that keeps the user's question within allowed boundaries. The goal is not to censor normal work, but to prevent the system from acting as a highly efficient search engine for sensitive material. A beginner might think the danger is only the model's output, but in our AG, the retrieval interface itself is a power tool. Power tools require guards, and the guardrails often live in the retrieval layer rather than in the model's wording. If the exam presents a case where users are probing for internal information, controls that monitor and constrain retrieval behavior are usually the safer focus. Prompt injection becomes more dangerous in our AG because the retrieved content can carry instructions that the model may treat as higher priority than it should. This happens when documents include text that looks like commands, policy statements, or persuasive language that tells the model to ignore safety rules or reveal hidden data. In security terms, retrieved content is not inherently trusted, even if it came from an internal repository, because internal repositories can contain untrusted inputs, attacker text copied into tickets, or simply poorly written content. A robust design treats retrieved text as reference material, not as instruction material, and it keeps system-level constraints separate from user and document content. Beginners sometimes assume that if a document is internal, it must be safe, but security history says internal content can be compromised, misleading, or adversarial in subtle ways. A defender approach includes clearly separating instruction hierarchy, sanitizing retrieved content when possible, and ensuring that the model is guided to treat retrieved text as evidence rather than as authority. When a scenario mentions a model being tricked by content inside retrieved documents, the defensive interpretation is that the system failed to treat retrieval content as untrusted. Another abuse path is poisoning, where attackers influence what gets into the retrieval corpus so the system retrieves malicious or misleading content later. Poisoning can be direct, like inserting text into a knowledge base, or indirect, like causing certain log messages or ticket notes to contain crafted language that is later ingested. The risk is not only wrong answers, but wrong answers that are consistently wrong in a way that benefits an attacker, such as recommending unsafe steps or downplaying indicators. Defenders address poisoning by controlling ingestion, verifying content sources, and applying integrity checks, much like protecting a software supply chain. You can also think in terms of provenance, meaning you track where each piece of content came from and whether it is trusted. Provenance matters because it lets the system prioritize content from reliable sources and de-emphasize content that is user-generated or adversary-contaminated. A beginner might assume the retrieval corpus is just a library, but in security, it is a library where attackers might slip and forge pages. Designing RAG defensively means building a librarian that checks credentials, not just a librarian that fetches quickly. RAG can also fail through relevance errors, where the system retrieves content that is semantically close but operationally wrong. In security, close is not always correct because details matter, like environment, privilege level, and policy constraints. If the system retrieves a policy for one business unit and applies it to another, it may produce advice that violates governance or exposes data. If it retrieves an incident response step meant for a test environment and presents it as production guidance, it may cause disruption. A defender manages this by embedding context constraints into retrieval, such as requiring matches within the same environment tag, system tag, or policy domain. The model's generation step should also be guided to indicate uncertainty when retrieved evidence is incomplete or conflicting, because confident fabrication is more dangerous than cautious limitation. Even without quoting, a model can mislead if it sounds certain and authoritative. This is why defender-style RAG design emphasizes grounding, meaning the answer should be anchored in retrieved evidence that the user is allowed to see, and the system should avoid inventing details that are not supported. A critical design choice is how much retrieved content you provide to the model and how you structure it in the context window. If you provide too much, you risk exposing sensitive details and overwhelming the model, which can cause it to miss the relevant constraints. If you provide too little, you risk shallow or incorrect answers that appear confident. Defenders often prefer a smaller, higher quality set of retrieved snippets that are tightly permission scoped and clearly attributed, because that reduces both noise and exposure. Structure also matters because models respond to patterns. If retrieved content is mixed with instructions, the model may treat it as instruction. If retrieved content is clearly separated as reference, the model is more likely to use it as evidence. Another practical consideration is that context windows are limited, so long conversations can push out earlier safety constraints if the system is not designed carefully. A safe approach keeps critical constraints consistently present and ensures that retrieval does not displace them. When the exam asks why a system leaked information after long interactions, context management and retrieval volume are often central to the correct reasoning. Monitoring and incident readiness are part of defensive RAG because even good designs can be abused or misconfigured. You want visibility into what queries are being made, what documents are being retrieved, and what outputs are being produced, in a way that supports investigation without creating new privacy risks. Logging should capture enough to detect abuse patterns, such as repeated probing for restricted topics, while also respecting that logs themselves can become sensitive records. A defender also defines response playbooks for RAG failures, like what to do if a leak is detected, how to revoke access, how to purge or re-index affected content, and how to notify stakeholders. This is the same lifecycle mindset you use for other systems. Plan for failure, detect it early, and contain it quickly. Beginners sometimes assume the primary risk is a one-time mistake, but in reality, repeated misuse can extract far more value than a single disclosure. Monitoring and response reduce that extraction window, which is why they are core to secure deployment. If a scenario includes suspicious user behavior, the best answers often include auditing and control adjustments, not just model tuning. Evaluation is another defensive necessity because our AG systems can look good in demos and still fail under adversarial conditions. Evaluation should include normal queries and also misuse-oriented queries that test whether the system can be tricked into retrieving unauthorized content or producing revealing summaries. It should include tests for prompt injection and for retrieval manipulation, because those are common failure patterns. It should also include tests for spillover, where you intentionally place sensitive material near relevant material in the corpus and see whether retrieval and generation stay within authorized boundaries. A defender also evaluates performance across user roles, because access controls should change what can be retrieved, and you want to ensure that the system behaves correctly for each role. This is not about building an impenetrable system. It is about reducing predictable failure modes and measuring whether controls work as intended. In exam terms, when asked how to validate AR/AG design, answers that emphasize adversarial testing, role-based evaluation, and ongoing monitoring are aligned with defensive thinking. Governance completes the picture because our AG is ultimately a way of delivering information, and information delivery is a policy issue. Governance means you define what kinds of data are allowed to be in the retrieval corpus, what user groups are allowed to query what, and what kinds of outputs are acceptable. It also means you define retention, because stored queries, stored retrieved snippets, and stored conversation history can become sensitive records. A strong governance posture also defines ownership, meaning someone is responsible for maintaining document classification and removing outdated or risky content. Without ownership, retrieval stores tend to grow into messy warehouses where old documents linger and sensitive content accumulates. Beginners often focus on the model as the main component, but our AG risk is often dominated by data hygiene and access boundaries, which are governance problems. A secure AG design is therefore a collaboration between security, data owners, and the teams operating the system, because the model cannot enforce boundaries that the organization has not defined. The exam will reward answers that treat our AG as a system requiring policy, not just as a feature requiring configuration. The simplest way to hold our AG in your head is as a pipeline where each stage needs its own guardrails. The user input stage needs trust boundaries and abuse-aware controls. The retrieval stage needs strict authorization and careful corpus design so it cannot fetch what it should not. The context assembly stage needs structure and minimal exposure so sensitive data is not unnecessarily shared with the model. The generation stage needs grounded behavior and safe failure so it does not invent or overshare. The operations stage needs monitoring, auditing, and incident response readiness because attackers probe systems over time, not just once. If you carry that pipeline mindset, you will naturally choose defensive answers that prevent spillover rather than trying to fix spillover after the damage is done. Our AG can be a safe and valuable tool when it is designed with least privilege, provenance, and continuous oversight. It becomes dangerous when it is treated as a shortcut to knowledge without respecting that knowledge access is one of the oldest and most exploited attack surfaces in security.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit BareMetalCyber.com.